Hello and welcome back. For this video we're going to show how to solve some exponential equations, but just slightly more challenging problems. Our first example we have here is 5 raised to the 9 minus 2x power is equal to 5x. Now just like before, we had to make sure that our bases are the same, and they are, and that means that our exponents are also equal to each other. So I can take the exponent of 9 minus 2x and set it equal to x. Then continue to solve for x. Add 2x to both sides. Then 9 will equal 3x. Divide both sides by 3. And x should equal 3. The next one we have down here is a little bit more challenging. You'll see the base here is 243 versus 3. So we're going to try and rewrite 243 in base 3. As it turns out that 243 is really 3 to the 5th power. So I'll bring down the rest of my problem, 3 to the 1 minus 2x power. Now that my bases are the same, I can set my exponents equal to each other. So 1 minus 2x has to equal 5. Subtract 1 from both sides. Divide by a negative 2 on both sides. And x should equal negative 2. Now you should go back and check to see that this works by substituting it up here into the problem, but I'm just going to leave it for right now. This last example is still more challenging. You'll see we have 3 different factors, 2 on the left, 1 on the right. 2 of them are in base 9 and 1 of them is base 243. So what we got to do is find a smaller base. And if you remember up here, we had a 243 that had a base 3. So I'm going to rewrite 243 as 3 to the 5th. Then I'm going to bring my exponent of k plus 2 down. I'm going to put it in parentheses also because I'm about to apply a power to a power rule here. That means I need to get the 9 in base 3. So that would be 3 to the 2nd power, and it's going to be raised to the 2k minus 1. And I've got 9 here, which I'm just going to call 3 to the 2nd power. Remember, the rule for power raised to another power is to multiply. So since I have a 5 here and it's going to multiply with k plus 2, I'm really going to distribute the 5 to the k and the 2. So I'm going to rewrite that as 3 to the 5 times k. It's 5k. 5 times 2 is 10. And then I'm going to distribute my power 2 here to my 2k minus 1. Bring my base down. 2 times 2k is 4k. And 2 times negative 1 is negative 2. And the whole thing is still equal to 3 to the 2nd power. Now I have like bases here with a multiplication between them. And we multiply like bases, the rule is to add the exponents. So I'm going to bring a common 3 down, because I have a common 3 here and here. And then I'm going to add the exponents. So 5k plus 4k makes 9k. And 10 minus 2 leaves me with positive 8. And this whole thing is still equal to 3 to the 2nd. Now I've got my like bases. I can set the exponents equal to each other. Now we just have a 2-step linear equation. Subtract 8 from both sides first. Divide by 9. And then I'm going to simplify that to negative 2/3. So k should equal negative 2/3.